Dear students, in this lecture we are going to learn about waveform distortion. We all know what is meant by distortion, right? When the received signal is not the same as that of the transmitted signal, then we can say the signal is said to be distorted. See, from one end of the transmission line we are transmitting signal to the other end. The signal that is received at the receiving end, it should be same as that of the signal that is being transmitted. Only then we can say that the signal is being received without any loss or without any distortion. But if this does not occur, that is when the received signal is not same as that of the transmitted signal, we can say the waveform or the signal that is being transmitted over the transmission line is distorted. As it is mentioned here, for ideal transmission, the waveform at the receiving end must be equal to the waveform at the transmitting end. This is for ideal case. Practically, this cannot happen. There will be some loss, some distortion happening in the waveform that is being transmitted from one end to the other end. And if the distortion should be absent or if the distortion should be nil in a transmission line, the conditions that has to be satisfied are all the frequencies present in the waveform that we transmit should have same attenuation as well as it should have same delay. Now if these two conditions are satisfied for the waveform that we are transmitting over the transmission line, then we can say the waveform will be without distortion. It will be received at the receiving end without any distortion. The condition is all frequencies should have same attenuation, that is same loss and same time delay. So if these conditions are not satisfied, then we can say that the distortion exists in a transmission line. There are two types of waveform distortion occurring in a transmission line. The first one is called frequency distortion and the second one is called phase or delay distortion. Let us see the definition of these two. Frequency distortion. See, this is related to the frequency, right? We are transmitting a signal over a transmission line and this transmitted signal will be having many frequency components present in it. Now, if all the frequency components present in a signal that is transmitted over a transmission line have same attenuation, then there won't be any frequency distortion. But practically, if whenever a signal having many frequency components are transmitted along the line, each frequency will be having different attenuation. The attenuation of all the frequencies will not be the same. Some frequencies will be attenuated more compared to the other. This is for practical case. So, because of this reason, that is since all the frequencies will not have uniform attenuation, the received waveform will not be the same as that of the transmitted waveform. And we name this type of distortion as frequency distortion. Right? So, all frequency components present in a signal will not be having same attenuation. That is the cause for frequency distortion. The attenuation constant in general, it is a function of frequency and it is given by this expression, which is alpha is equal to root of Rg minus omega square Lc plus root of Rg minus omega square Lc square plus omega square Lg plus Rc square by 2. This is the attenuation constant alpha. Right? Now, if I want to reduce this frequency distortion, the reason for frequency distortion is all frequencies are having different attenuation, right? So if I want to reduce this distortion, the attenuation constant alpha should be made independent of frequency. Now if this attenuation constant, that is if in this expression, if we make this attenuation constant independent of the frequency term omega, we can reduce frequency distortion. The other way in which we can reduce frequency distortion is by inserting equalizers at the end of the transmission line terminals. We can reduce this frequency distortion. The second type of distortion is called delay distortion or phase distortion. And this is with respect to the time delay that is happening. See, whenever we transmit a signal having many frequency components, all the frequencies will not be traveling with the same velocity, with the same speed. Since each frequency present in a signal is traveling with different velocity, the frequencies will be arriving at the receiving end at different time, different instance of time. That is the cause for phase distortion. That is mentioned here. When signal having many frequency components are transmitted along the line, all the frequencies will not have the same time of transmission. It will not be receiving at the receiving end at the same time. Some frequencies will be delayed more than the others. This is the cause for phase distortion, and it is related to the phase constant beta. The phase constant beta is a function of frequency, and it is given by this expression. And if I want to reduce the phase distortion, one way is we can make this phase distortion independent of frequency. Frequency distortion can be reduced by making alpha attenuation constant to be independent of frequency, whereas phase distortion can be minimized by making this phase constant independent of frequency. The second way to reduce this phase distortion is velocity of propagation is independent of frequency. And also we can make use of coaxial cables for reducing this phase distortion. This is all about waveform distortion in a transmission line.